Hey, Dr. Hyde. I hope you're feeling a lot better, and I hope you start feeling better soon. I just wanted to apologize beforehand about using a couple of my candles to hold up my phone. It's the only thing I could find to kind of view the paper like I needed it to. But let's get started. The Wiggers diagram looks very complicated when you first look at it. It has aortic pressure, atrial pressure, ventricular pressure, an electrocardiogram, ventricular volume, and a phonocardiogram. The Wiggers diagram is actually a lot simpler to understand than you think. For instance, we have a heart. That heart can depolarize, it can contract, the pressures in the heart can change, and we can see how all of these go hand in hand with one another on this Wiggers diagram. We'll start with depolarization. Depolarization can be seen on the electrocardiogram part of the diagram. Uh, Depolarization in short means to make the heart more positive. I have this potato shaped heart with everything drawn out already. The SA node up here fires and causes all of these negative charges to then go positive. Let's see, make all of these positive. It's kind of like a domino effect as the heart depolarizes all the way down. When the heart meets a certain threshold, it actually contracts. What I mean is that the heart pushes in here, and it also pushes in here into the ventricles, which causes the blood to shoot out of the aorta. There are also forces that act on the heart. I've got another potato-shaped heart, like he told us to draw throughout the semester. As you can see, it has an aorta up here. It's got two atria. It's got the two ventricles down here. At first, the atria is going to depolarize, which is right here, causing the atria to squeeze in or contract, allowing the blood to move through the valves into the ventricles. The depolarization continues down the heart through the Purkinje fibers and wraps back up the sides of the heart. This causes a force to be placed on the heart, which pushes in the ventricles right here, or which pushes in the ventricles right here, and causes the blood to shoot out through the aorta, allowing blood to get to the rest of the body. Since there is a force in the heart, this causes pressure. Let me get my Wiggers diagram back out. Pressure is at the top part of the diagram, which is right up here. It looks very confusing, but it's just trying to show you all the different pressures in the heart as it goes through different contraction and relaxation phases. These pressures cause gradients, which is just the direction of the blood flow. For example, the PQRS T complex is means it's just trying to show you the depolarization of the heart. This causes the heart to contract. This contraction can be seen on the aortic and ventricular pressure right up here. As you can see, where the aortic valve opens right here, it lines up perfectly with the QRS complex because the pressure builds up so much, and these valves are like doors and they open. I also have a house drawn for you already. We have one person on the outside of the house pushing in with a certain force, and we also have another person on the inside of the house pushing outside with another force. If one pushes with a stronger force than the other one, the door will most likely open. If they both push with the same force, that door is probably not going to move and it'll stay shut. We see this on the Wiggers diagram where the aortic valve builds up a lot of pressure and opens. Since the pressure in the ventricle exceeds that of the aorta, the valve opens. As you can see in the ejection phase, let me get Wiggers diagram back out. As you can see in the ejection phase right up here, the blood is going out through the aorta since the pressure is so high. And so this kind of explains the Wiggers diagram a little bit, as you just saw. It's not that hard to understand because it's all kind of connected. And that's about it.